All right. Hello, everyone. Feel like I should curtsy. So before I actually get started, who here has even ever seen F#? Awesome. OK. Are there folks here who are fairly comfortable with it? Perfect. Absolutely perfect. And who here is mostly focusing on iOS dev? OK. So all of my samples are in iOS. I realize this says cross-platform. I noticed it pretty much this morning that everything I had been creating was iOS only. I was like, well, oops. So it is an iOS talk. I do apologize for that. But I wanted to let you guys know as soon as possible. I also have a ton of stuff to get through, so I'm going to jump right in. The absolute basics. We're going to start the absolute beginning. Sort of can't get more fundamental than this. Let is how you define something. X in this case is a value, not a variable, because F# is immutable by default. And I always like to start with immutability because that confuses and concerns a lot of C# devs. You guys don't really know what to do with that. It's not a mode of thinking that is often something you work with. But if we go back, in C# and many programming languages, this would actually make sense. This x equals x plus 1. That's totally reasonable code. You're just incrementing by 1. But the F# REPL outputs that to bool equals a Boolean. It's false. And if you're looking at it, x equals x plus 1, that's completely awful math. You can't do that. That's something that your math teachers would just completely yell at you about. To go back, F# has a REPL. If you guys have been working with Xamarin Studio, or if you've been using Xamarin in Visual Studio, then you can hit Control-Enter or Alt-Enter, and you get a REPL that pops up at the bottom of your screen. You can enter code in if you're using a script file, automatically evaluate it. It's very fast. It's very easy. It's something that I know that Chris Hardy mentioned in yesterday's keynote. So if you hadn't heard the term REPL before, F# also has one. So moving on to a slightly more complicated example. First, we have a list here. We're taking that and just filtering. We're grabbing just the even numbers. Then we're adding those even numbers, incrementing each by 3, and then we're summing those. The total for this code, we take this list, and we end up with a value of 45. If English doesn't work for you, then filter is just a where clause in LINQ, and map is a select in LINQ. So that should translate over exactly. You guys should pretty easily be able to translate that. Higher order functions are also something that C-sharpers should be fairly comfortable with at this point. But it is a mainstay of functional programming, just being able to pass around functions as first-class citizens and using them in several different places like this. So first of all, pipelining, like we have here, this taking 1 to 10 and piping it into this list.filter and then piping the result of that into list.map. That's something that if you guys have done any Unix shell scripting, or I know that PowerShell has a pipe as well, that is a concept that perhaps you've seen before. But it just basically takes the output from from the previous function and passes that in as input to the next function. And pipelining itself is so important that F# actually used that as inspiration for their brand new logo. Because yay, we have a new logo. Which is awesome. So if you all haven't seen F# with iOS, then here's just your basic app delegate. If you've done iOS programming, this should look fairly familiar. We have an app delegate. We're inheriting from the UI application delegate. We have a window property. The finished launching method here creates a new UI window. The only thing that most of you will have messed with mostly in the app delegate is the setting the view controller. I actually wrote a version of Minesweeper, and so this is my exact app delegate for Minesweeper. I actually won't be demoing that today, but if you wanted to look it up, it's on GitHub. And then down here, of course, we have the main entry point. So why F#? I used to start this talk with a why Xamarin slide, but I took those out because I know that you guys all know just exactly how amazing and awesome and wonderful Xamarin is. Part of me was a little sad to take out the slide because it had some of Craig Dunn's at Concepts monkeys on it, and it was really a fabulous slide. But obviously, we're all here at a Xamarin conference, and we know how amazing Xamarin is. So why F#, right? Well, F# has, has what's called the option type. And null reference exceptions can be completely obviated by using this option type. It's very similar to a nullable type, but excuse me, it can work on any type. So instead of just having nullable ints and the few other things that nullables will work on, you can have nullable functions. You can have whole nullable of anything at all. You can pattern match on them, and I will talk about pattern matching in like 2 slides. But keep in mind that you can pattern match on option types. You can also use the functions that I showed you with lists just a couple slides ago. You can use mapping and iterating and other functions on option types as well. So they end up being very, very useful. You can also nest them. So you can have an option of an option type, which is something that you definitely can't do in C#. Plus, this is a great joke. Another thing, if you consider a fairly basic object hierarchy like this, when we have a transport class, a simple base class, the first car takes a make and a model here. 2 strings come in. Bus is one of the child classes. Here we have an int route. So it takes in different things. I couldn't actually quite get what I wanted to say for bicycle on there. I didn't want to make the code so small you guys couldn't even read it. But if we have, say, this base class and then these 3 inherited classes, that's kind of a lot of code. That'll be 4 different files in C#. If you want to add something else that inherits on it, that's a whole new file. That gets really complicated. That ends up just adding to the amount of stuff in your solution, when this can be a lot easier and more, I think, beautifully done in F#. The very simple, it's called a discriminated union. It contains exactly the same information. So car here is a type, takes make and model in as strings. Bus has the route information, and bicycle. It's those 4 lines, and you're done. You've been able to model that completely. And then any new one that you add to that just is 1 extra line instead of 1 entire new file. So it reduces your code tremendously. This is also trivial to pattern match on. I told you guys I was getting to pattern matching. So pattern matching is sort of like a switch case statement in C#, except that in C# you can pattern match on precisely one sort of thing, a constant of some sort. In F# you have 16 different types. You can pattern match on lists, and you can decompose them while you're doing that and take out the elements of this. Whereas C# has just the one constant pattern way at the top. So I'm not going to go through all of these, but I want you guys to go look this up on MSDN and play around with pattern matching, because there is just so much there that you can dig into that is really very incredible. So like I just said, discriminated unions work really, really well with pattern matching. They're one of the things that you can pattern match on. And F#, in fact, the compiler will warn you if you haven't fully pattern matched on everything. So here we have the car, the bus, and the bicycle. Whereas if I have a function that is trying to pattern match and return some sort of information based on which thing was sent in, I don't have a bicycle type. So it will actually warn me that bicycle is something that should be here, and it's not. Which means if you add an additional type, if I add a train sometime later, the compiler will automatically warn me of the 8 different places in my code where train should be being matched on and isn't. And so you know instantly the changes that you need to make. You don't have to sit there and fuss with it and step through everything and hope you didn't miss a case and find an error at 3 o'clock in the morning, and it ends up awful. So we've discussed so far several reasons why you should learn F#. It's mutable by default. You have option types, discriminated unions, pattern matching, and the REPL. We haven't discussed custom operators, but you can create completely your own operator. in any bit of code, there's, if you need some magical operator to add one, you can create something like the fish operator. And that can be the way that your program adds one. So any newbie coming into your bit of code can now use this fish operator to make sure to increment. It's fun. But if you notice, Swift has all of these things as well. So anyone you know who is telling you that Swift is the new best thing since sliced bread, and I don't know that any of you guys would believe that anyway, right? But anyone who is telling you that, you can come back to them and say, well, F# is awesome, and in fact, F# is way more awesome because we have all of these things as well. First of all, Swift isn't even Swift is single platform, but there's no units of measure. There's no type providers, and type providers I will talk about in a minute. But it's missing all of these things that F# has today, and will obviously have way more things. So, F# is amazing, right? So Xamarin Forms. Every time I do this talk, somebody raises their hand. It's like, wait a minute, but can you use F# with Xamarin Forms? So, right, can we? So, yes. Why, yes, you can. It's not much to the. So let's check out what a very simple hello world Xamarin Forms application looks like. Perfect. So here we have my iOS app delegate here. It's fairly similar to the one that I just showed you guys with my Minesweeper view controller. I still have the window property. I have a finished launching. I call forms.init, and in the root view controller, I set my app.getMainPage, and I create view controller. My app.getMainPage is a super, super complicated. I'm creating this label. I'm centering it, and adding it to a page. I know this is practically rocket science, but here, we will run this. And I'll show you guys that I'm not joking, and it really does actually work. Yay! So F# with Xamarin Forms is totally possible. Back to slides. I want to talk about type providers. Type providers are another big, important why F# topic. So what are type providers actually? It's a mechanism to provide typed info to the compiler from an external data source. So if you have, SQL Server or a WSDL, or there's a few different databases online. There's, a website called Freebase, which is a community-curated free database of information. The World Bank has a type provider available to it. And all of these basically, you can hook them into your F# code in just a line or two of code, and then you get full typed information on that entire data source. It's pretty incredible. Why really do we need them? If you consider our current data consumption methods, and it's not so complicated. It's something that I know that C# devs do every day. But first you have to set up the connection. You have to obtain all of your data. You have to create all of this infrastructure around this. In some cases, using an ORM, there's massive amounts of code files that are generated, and they all just sit there waiting to be updated. And then, once all of that has been done for you, then you can actually consume and use the data that you were trying to get to in the first place. And with F#, that's literally 2 lines. It's always in sync with the source. If you're going out to, say, a WSDL, when you load up the project in either Visual Studio or Xamarin Studio, the type provider will ping the schema and say, hey, has anything changed? What's going on here? What does this look like now? Are all the methods that you're trying to call, do those all still actually work? And in some cases, obviously, it doesn't. If the schema has changed out from under you, you will know the moment you load the project that stuff is different and needs to change. There are ways to turn that off if you, for instance, don't have internet access, then you can still compile your code. But I think of that mostly as a feature that you will know instantaneously when stuff is different. And because of that, because everything is brought back into your code, you get the perks of all the IntelliSense and the tooling, all the stuff that your IDE will offer you. Excuse me. So you get IntelliSense. I mean, you can, if you're going out to SQL Server, once you've set up your connection, you type dot, and it will give you a list of the tables. You choose one, type dot, it will give you a list of the columns that you should be looking at. And from there, with some of them, and there are a couple different SQL providers, but it can show you the actual data within that column. And you can end up just playing around with your code and exploring and making sure you know what's going on. There's also no code generation. And this tends to confuse people a little bit. But it means basically that even if you're using, there is a SQL provider that works with Entity Framework. And even if you're using one of those, all of that code that Entity Framework would normally generate doesn't stick around. It's not just waiting there, not sitting there waiting to be updated, getting stale and hanging around. That doesn't actually happen. And because of that, type providers end up being scalable to millions of types. The Freebase database, as well as the World Bank, both have hundreds of thousands, and I think one of them has millions of types. If you think about trying to connect Entity Framework up to a data source that has millions of types and how that is actually going to go, I mean, you'll be sitting there waiting there for a week. It's not going to happen. Maybe a month, I don't know. But it is completely scalable. I'll show you guys in just a minute. So in this case, I'm actually going out to connect to the World Bank. I'm using a script file, so if we notice, down here at the bottom is my REPL. Open is just a using statement. This line here, let WB equal World Bank data dot get data context, that is calling the type provider that is opening all of the data. And that is done. From here, I can call WB dot countries dot, you get the entire list of stuff that's available in the World Bank. Let's go to Denmark. Indicators are what holds all of the information. So we have, a huge amount of information that's available. Gross fixed capital formation. Let's try 2010. Right, so that's 5.29. So the gross fixed capital formation in current US dollars for Denmark in 2010 was 5.29. And obviously, you can do that for all of the countries and all of those different indicators, and it's just completely at your fingertips and can be included in all of your apps. Kind of insane, right? So I'm grabbing here an array of countries. And in this case, I'm going to return a triple of the country name, the population total, and the internet users per 100 people. So for each of the for each of those countries above, we have that. And then we're going to sort it and grab the max, which is Iceland. So Iceland has 93.39% of their population is online. And of just this random sample of 15 countries or something that I chose. And Cambodia has 1.26. So you can imagine what sort of information is available to you with stuff like this. There are zillions of type providers. This is just obviously a handful. There are some ridiculous ones. There's a choose your own adventure one, which literally every time you hit a dot and the IntelliSense kicks in, you get a new little adventure that you can choose, and it's just an ongoing loop of them. It's fun. There's useful ones. There's an RSS one. There's Python. A lot of people use the R one. So if you have scripts set up in any of these languages, you can farm your code out to that and get an answer back. There are so many and so common, and so many people are creating them that there's a type provider for that has really become a joke in the F# community, because it is such a common thing. Well, is there a type provider for that? Yeah, sure, so-and-so is starting to build one. But so one other point about this, you can actually combine type providers. You can have 2 or 3 in a solution in a file if you wanted to. As long as you have all the correct open statements, you can just start calling them. They're just like any other bit of code. But it means that you can start doing things where you get data from one location. You can grab from a CSV file and Hadoop if you wanted to, and then process it with PowerShell if that's what you needed to do. And there are a couple different ways of visualization. I mean, there's not a type provider for F# chart, but that is in F#. But you can visualize with R. There are a couple really great demos where this guy named Matthias actually will go and get a bunch of information from the World Bank and then graph it in some really amazing ways using R, all in like 40 lines of code. And it's really incredible to watch some of those demos, just to see what is possible. So just think about the possibilities here. And especially with Xamarin, with iOS apps, there's a SQLite type provider. So I mentioned that to you guys. I want to show that off now. I rewrote Tasky, everyone's favorite awesome Xamarin To-Do app. It's not that fascinating, but here we have, to finish the laundry and read my book. I can add a new task. Finish. Hit save. Go back, it's there. I can scroll over and hit delete. If I highlight it, I can hit complete and save that. It no longer shows up. If we pop over here, you can see that the last thing I had in my database in the SQLite was go to evolve, since I forgot to show you guys before. And now I have finished my evolve talk, and it has 1 for being completed. So it really is going out to the database. There's no smoke and mirrors or anything here. Oops. And if you look at the data layer, we have a connection string right here. Just grabs the local task.sqlite. It's in my resources directory. And this line here, or this couple lines, it's all really one line, that is the type provider. I'm connecting out to that. The first line is the connection string. The next one is that it is SQLite. This particular type provider works with a couple other things. It works with Oracle and SQL Server itself. The resolution path, which is where the mono.data.sql client is located. And then whether or not to use option types. In this case, nothing I'm returning is nullable, so I happen not to be. I'm declaring a task record. Records are sort of like tuples, but they're named, so you can name the different pieces of them. And then I have the second line where I'm just doing a SQL.get data context. So these 2 lines here, type SQL and the CTX, that is my entire, connecting out to my database. That's all I need to do. The rest of this here is the rest of my data layer. So I have getting my incomplete tasks, which are what I show on that main screen. I have a find task, and this uses link syntax. You can see I'm, for data in context.main tasks, when data is complete, then select straight into the record that I created. A find task I use in deleting and updating, just to find the specific task that I need to delete or to update. It finds it by ID. So if we look at those 2 first, they're very, very similar. I first find the task that I'm looking for. In the deleting case, I delete. In the updating case, I update the relevant information. And then in both cases, I do a submit updates. And that's what you guys saw in action that does the either deleting or the updating. For adding, it's fairly similar. I do a new task is context.maintasks.create. I create a brand new context, and then I fill in the information here. This backwards arrow is how we handle mutable assignment in F#, so you guys know if you haven't seen that before. And then we submit updates, and that will add a brand new task. That, in 47 lines of code, is my entire data layer for the application. It's teensy tiny and completely effective. If you wanted to look at the rest of the code, just to show you guys that this is what other iOS code might look like. I have my add task view controller, which is that second screen where I'm actually adding. In my view did load, I create an add view that is the subview that I'm going to add everything to. I set a description field. The text field that I enter everything into has a placeholder of task description. And then I add that. I have a complete label and checkbox, just the label that says complete and the checkbox of whether or not it's complete. And then a handler that shows whether or not that's on. My added label at the bottom that said whether or not it was added or updated. I have a bunch of code here for my add update button. So I create the button, and then I either add or update a task, depending on how that's going, and add all of that stuff to the view. For the main view controller, it's a little more UI code. I create a task data source. I set the rows in section, do the get cell bit with the dequeue reusable cell to make sure that when I have too many lines, it'll queue properly. I set the row selected to, if I select the row, I can add the new task. I can edit the row. This is the part where I actually set the deleting to happen. So I delete the task actually from the database, and then I remove it from the task list that I create, and then I'd remove it from the actual view. And then, in my view did load, I set up my add button up in the corner and set a few things on the table. And view will appear. I set the task data source to actually set that to be the source of the table, and then reload the data. So it is pretty simple. I am going to continue on because I have a couple more things to talk about, and we're low on time. But do you guys have any questions? Do we all understand that? We're good? I see some nodding. So mailbox processors. Mailbox processors are, they're sort of F# implementation of what the actor model is. The actor model, if you guys know any Erlang, is what Erlang is heavily based upon. So I wanted to step back and cover what the actor model even is. It's basically a concurrency model where interaction is through direct asynchronous message passing. It's, a concurrency model. So there's lots of concurrency. It's an actor is an independent computational entity which contains a queue and receives and processes messages. So if you look at the awesome picture I have over here, it's not usually this complicated. It doesn't have to be this complicated. But I wanted to show you guys a very scary picture off the start. But we can think of each one of these little pieces as an actor. And each one of them might have messages coming in and a queue coming in, and process those messages as they happen. But most importantly, one actor is no actor. I think it was Carl Hewitt that said this. Carl Hewitt is one of the guys who wrote the original paper defining what the actor model was. And they come in systems. So if you think about having the only telephone in the world, you can't really call anybody. Maybe you have the only subway stop in the world. So you have a train that can loop around to that one stop. There's not really, your messages can't go anywhere from there. You just have this one place to sit. If you have, so like I was saying, the actor model doesn't need to be complicated. If you have code that sort of looks like that previous slide, using agents and mailbox processors, you can make it look a little bit more like this. The important part of the actor model, and especially in F#, is that it's about getting where you need to go. So if you're down here in one of these lower stations, you can easily get up here. It's a matter of being able to make change bits and pieces. But if you think about each of the stations as a specific actor, a train pulls in, some processing happens. Maybe some people will get off and switch to a different train. Maybe some people will get off and leave entirely because they crashed and they're non-recoverable. Not always necessarily the best analogy. But the trains will continue on to different stations. There is a way to get from anywhere on this map to anywhere on this map. And it sort of cleans it up. It gives you a map of how things can go and where things can interact from and to. So looking at the absolute basics of how this works in F#. So one thing, it's called the actor model. In F#, it's called mailbox processors. I've also heard them referred to as agents, to the point where many, many people, just because agents is a shorter word, will alias the type in their first, way up at the top, and then just refer to everything as agents. So actors, agents, and mailbox processors are all basically the same thing. Don't let that confuse you. But we define agents and mailbox processors here. We have the way we set one up. So I'm declaring one in this bit here. We have agent.start. Basically, I'm saying declare and start this one, start it up immediately. That takes a function here that has an inbox. So that's the way it takes in messages. And it handles them by going through a recursive loop. So in this case, my loop, it's just handling some state. There's an async section inside. We do a inbox.receive. That's how you actually receive the message. And in this case, it's just saying, hey, I got this message, and state is now this. I'm not doing a whole lot with the state. I'm passing in state +1 the next time I loop around. So it's not too complicated here. You can be doing much, much more with that. But I start the loop at 0, and then that just keeps going. As a side note, let message equals inbox receive. That is blocking, so it sits there and waits for a message. And then once it receives one, we'll do all of the processing and come around, and then sit and wait for the next message. If I do, to actually get messages to post to the agent, it's agent.post. And in this case, I'm just posting a string of hello. This is basically a finite state machine. For looking, I'm recursively handling state here. I have some state. I do something with it, and then I modify it. The next time we come around, it's new. The output in the REPL looks like this. Got message hello with state 1, 0, and you can keep going on and on and on. If the state is something that you're trying to handle, this probably isn't something that you want 100,000 threads to be spun up to do. This is something you could spin up 100,000 different agents to do. It's much easier. And I have a very cool, completely new to my talk demo just for Evolve, which is a stock ticker. Completely realistic stock ticker, I might add. When I start this, I have Apple, Microsoft, and Google stocks. And Microsoft is was tanking and is skyrocketing now. But you can see this code is quite tiny. I don't know how well you guys can see that. But for each one, I had 1,418. And for Microsoft, for Apple, and Google, I had 1,421 different posts back from those agents to the line, to the chart on the screen. So 4,500. And I am doing that with agents here. So one more thing about agents. This async reply channel is how you get a response from an agent. So you can post to it. Normally, you just post to it, and that's it. Your message goes off into oblivion. But with an async reply channel, you can get a response back. And the way I'm handling my loop is that it posts the current stock value to the loop, and then modifies that a little bit, returns that to the UI, and then starts a new loop with the new value. So it just continues going on and just keeps sending new values off to the UI. I have an agent state stopper started here. Here's my mailbox processor. Here's my recursive loop. It's very similar to the one that you guys just saw. I actually had to do an async.sleep too, because if I don't have that and it doesn't sleep, it actually doesn't look real because the stocks jump so quickly that it doesn't look like, it looks like I'm faking it and pushing like 400 to them at once, 400 to the UI. So I added an async.sleep too, and it looks more realistic. It's programming, right? So I'm receiving the messages here, and then in my highly scientific, research for years method to determine how stocks actually behave, I randomly modify them a little bit. Reply channel.reply is how I'm actually sending back that reply. So it's a very simple, that bounces it over to the UI, and then I just, recursively loop again. Down here, when I start the agent, I also make sure to start the loop. So this is the one agent that I've defined, and then I specifically instantiate it 3 times. I have the Apple one at the top, the Microsoft one, and then the Google one. So I have 3 different agents running for each one of the stocks. In my stock ticker view controller, similar to the rest, I register the top. My type inherits from UI view controller. I set the agent state at the beginning to be stop. And then I'm using tchart here, which I haven't used before and was quite easy to use. But the way they handle adding a new line, because I have the 3 different lines all plotting to the same place, is this styles.fast line. So I title each of them. I have the Microsoft, the Apple, and the Google. Here's my draw line function that actually does the drawing. So I have to send in a bunch of information here. N is this n that I had down here that I read to you guys was 1,400 something. So that's just where that comes from. That's the number of times it looped in that short period of time. The agent state, whether it's stopped or started. The actual stock, if it's Microsoft, Apple, or Google. The specific line, because I need to add to that line to post to the UI. And then the specific agent that is being called so that I can call it and get the response. So once I have those bits of information, obviously if it's stopped, I just do nothing. I stop. I don't post anything. If it's started, then I do a post and async reply. And that's how the bit of code that I showed you before was just posting. To get a reply, you need to do a post and async reply, just slightly different. And then you respond here, or you receive the response with a start with continuations. So the first one is if it's valid. The next 2 are exception and cancellation. In this case, I'm not handling errors, so totally production code. I print down to the console window just so I know how things are going. I add the reply as a new bit in the line, and I recursively draw the line. And that is most of what the draw line, or how the lines are being drawn. I have a very long, oops, don't move that. I have a very long section to create the segmented control. I set the coordinates. I insert the start and stop segments. I set which one is selected. The handle segment changed is my event handler. So if I basically reset the agent state to stop or started, and then I call draw line again with the new agent state, and it will stop or start depending on what should be happening. Then I make sure to add the handler. So in view did load, I'm basically creating a UI view that I will then add everything to. I set up the chart. I add the 3 lines, chart.series.add. That's how tchart handles adding the lines to the chart. And then I add the chart and the slider to the stock view, and I add the stock view to the main subview. And that is basically it for creating, using agents to handle automatic posting to the UI. It's kind of a lot of fun. Thank you. And that is it. I have one more thing to say. If you guys liked my talk, if you liked F#, then Larry over there is speaking tomorrow, and you guys should definitely all go to his talk. It will be just as awesome. And are there any questions? We have just over 5 minutes. All right. Oh.
In your database example, you had the task record, and somehow there was a task.delete member method on it, and I was curious where that .delete came from.
let me.
In your data model, yes.
Yeah.
So the record doesn't have it, is that right?
No, this is me. Yeah, that's not my best. That is a little confusing. So no, I'm defining task right here as finding the task. And so I'm going out to the database, and I'm returning an actual task. Here is the entity, which does have a delete method. It's not the record.
Oh, it's a generated class for you? Okay,
Yeah.
thank you.
I will change that, though.
I was curious if you have any advice on when F#, Xamarin, and are there cases not, or is it just Go? Or I mean, I'd just like to. I mean, I know a lot of people are probably wondering about is this feasible, or is this like a you know what I'm getting at?
Yeah, it is fairly feasible. I think the biggest drawback is that Xamarin just hasn't hired enough F# engineers, and yes, and so when there are issues, it's it's all on one guy to solve, and that can be a little bit difficult.
I've been kind of observing functional programming languages for a year or so, but I've been kind of a person that's been afraid to get my feet in the water. So I'm guessing it sounds like you're familiar with like Erlang and those sorts of languages and stuff. And
somewhat.
Okay, from my perspective, it seems like that F# doesn't seem as, I don't know, functionally pure as those other languages. So could you comment, what would you say to somebody who said that this was like an abomination because it's not functionally pure enough and all that? Like, how would you address that? Because I'm going to have to, my CTO at my company is this person, so if I want to use this, I'm going to have to.
Okay.
So any help you could give me would be appreciated.
Honestly, it is not functionally pure. I think that it is more functionally pure than some languages and less functionally pure than others. It's not Haskell. I think that's a really good thing because it means there's a lot more real-world scenarios that you can just code to and just actually get working code a lot faster and a lot more simple. It does mean that mutability will creep in sometimes. My advice there is to just be uber careful about where it does. If you train yourself from the beginning to think as much like somebody who is interested in pure functional programming, that will help. And then in the cases where you just can't do it, the out is there. So yeah, I would say that's a good thing.
Thanks.
Yeah. All right, then. I am here if you guys have any other questions. Thank you tons.